Here we go. Hello there, everyone. Welcome, welcome. It is 2 hours UTC and time again for Astronomy Daily Live. So welcome. Come on in, everyone. I'm going to get my chat up here so I can at least sort of see it a little bit. Yeah, there we go. All right. Well, hope everybody's doing well out there. Come on in. Come on in. This is just a fun, casual gathering of friends practically every single day, coming together on this sort of virtual porch with our, consumables of choice. I've got the HOH again today. Yeah, just a incredible molecule, and I like it too. So cheers. So on the panel is Tom. Hey there, Tom.
Hey, Cosmic. Hey, everybody. Hope you're all having a good day.
And Bobby's on the panel too. Hey, Bobby.
Hey, what's up?
So, Bobby, you had a couple, well, at least one International Space Station pass, and two, cool. And I noticed I'm gonna go to share right away here. Take a look at these. You posted over on my Discord server somewhere. There they are. There they are. So talk about these a little bit. What are we looking at here?
Okay, so the first image that you're going to see right here is the one around about 5:15-ish a.m. local time on a Monday.
So that was this morning.
I think I had like a 50-something degree pass.
What does that mean, a 50-degree pass?
The elevation.
I gotcha.
The greater the elevation, the more better the opportunity.
Yeah, because I mean the elevation is directly related to how far away it is, right? And also like how much air it's moving through. I guess radio waves really isn't affected by atmosphere or air much, but I mean it's distance, right? So if it goes straight overhead, 90 degrees, that's as close as it's going to get, right? So if it's anything off of that, it's going to be, it's some kind of function. It's probably like a cosine function or something like that. And so, 50 degrees maximum is, that just puts it at a longer distance away. Now, in this image, I mean, it's pretty, it sort of looks like one side sort of came through okay, but then it sort of deteriorated, or maybe the other way around. So what's going on there? What causes that?
Well, it's like I said, that 5:15-ish local activity is even though I still got like a 52-degree pass opportunity, at least I was able to capture it, but like I said, it pretty much faded within the distance.
I got you. So, I mean, what these are, right, is that the radio signal has this information in it, and then you have to use like a decoder or something to actually make the image. Is that right?
Yes, that's correct.
Cool. So
I used a QSSTB since I have a Linux machine.
Oh, no.
But if you do it under Wine, you can try to get MMSSTB to work.
Okay. And so those are decoders, right? So they take the radio signal.
These are called slow scan television decoders.
Cool. And so this is, I mean, all this down here is just because you weren't getting any kind of signal. Is that why it's all messed up down here?
It kind of like a little bit fainter during this endeavor.
Gotcha. So yeah, it's just a signal to noise thing. So okay, yeah. So did it scan from the top down or from the bottom up? Or
Top
from left?
down.
So top down. Okay.
Yeah.
Cool. So somehow the software knows or is told what the dimensions are, or do you have to tell it that?
So like when it detects when the decoder detects the signal, it should do it automatically.
Oh, cool. So yeah, that kind of information is sent also. So some of the metadata, right? So that's kind of cool, and it's really, really cool that it's in color too. I think that's absolutely fabulous. There's a lot of information in there. So cool. Well, I think the other one. Now, was this on the same pass, or was this a different one?
Okay, this one was mostly like around 1:10 p.m. local on a Monday, and this is a 78-degree pass opportunity, so I had like a better chance.
Yeah, and it was right in the middle of the day, so I mean, visually, you wouldn't be able to see it, but of course, with the radio, it's nice and bright.
Right.
Yeah, cool. So again, I mean, a little bit of noise here at the beginning, but then wow, it cleaned up really, really nice, really, really nice. So cool. Yeah, these are the kinds of things that you can do with a radio receiver and a little bit of software. You get to you're not exactly talking to the International Space Station, but you are getting data from it, and that's pretty darn cool.
Yes, it's pretty darn interesting as well.
Yeah. So how long does this picture take to download or to grab?
Usually if you have a good signal, it usually takes about like maybe 1 to 2 minutes for the complete image to download.
I gotcha. Yeah, because and the reason why I asked that is because I know that a pass of the space station is usually no more than about 5 or 6 minutes. So you have to be able to grab this whole image in less time than that, because otherwise, of course, if you're not able to get the signal, you're not going to get a picture. So the ISS has to be up. So cool. So this just takes a couple of minutes to grab. Wow.
Yeah.
Pretty nice.
And I would have had one more if I actually did had about, like, let's say 2 more minutes until I have a loss of signal.
Oh, okay. Yeah. Well, very cool. Very, very cool. So yeah, that's
during the transfer, I actually was out of order.
All right. Well, cool. Very, very nice. Very nice. So, let's see. There was a little bit of Soyuz news today. I guess I haven't. I still haven't heard anything about that launch that happened a couple days ago. So, if anybody knows anything about that, I'd like to hear. But I guess they are planning a manned launch in December. Is that does that sound about right?
Yeah, I think that's what they said. The Soyuz they thought it was ready to go, but they're going to re-examine the boosters and make sure those things are connected properly and they don't have the same issue that they ran into. But it looks like they're going to be ready for launch.
So the has the exact problem actually been sort of publicized or anything yet?
I haven't seen anything online anywhere. Uncle Bill said he had seen it on one of the podcasts, TMRO, Tomorrow podcast. They had talked about it, but I haven't seen a report of it that's official. This one place I did find didn't really mention that, they didn't really describe the issue. All they said was they were going to check the booster connections and then reattach it and make sure it's ready to go. But they didn't really say, what happened.
Yeah. I think the only thing that I had heard, and this is sort of old news, is that they found some bolts or something that were not properly installed. So yeah, I should probably go over to Tomorrow and check out their thing. I missed their show this last Saturday. Tomorrow does a sort of a space and astronomy show every Saturday at, I believe it's 18 hours UTC. During that show, well, one, it's extremely fun to Uncle Bill, you make me blush there a little bit. Yeah, but they talk about space launches.
Tomorrow podcast is just TMRO, right?
Yeah, I think if they have a YouTube channel which is TMRO, and then I think their website is tmro.tv, if I remember right. And yes, I am a Patreon member over there, giving them just sort of loose change every month. So but they that is well deserved, and definitely something that I want to support, because they're a good group of people, and more than anything else, right? It's really, really, really great to watch their live stream, because they usually start the live stream 15 to 30 minutes before they actually start, and it's extremely rare that they start on time, right? Because there's 5 or 6 people there, and they're all talking at the same time, just having a complete blast. And that's why I like to support them, because they are having so much fun, and I like to support those kinds of things.
Now, Uncle Bill, can you post that on the Discord for me, please? So, after this show, I might see about watching it.
Yeah, if you've never seen Tomorrow, definitely. So the live stream, right? Like I said, it starts 15 to 30 minutes before they actually start the show, the official show, and then and I don't think that they've ever done this either. I don't think that they've ever made it through an entire show without having to stop, because they forgot to move chairs, or they forgot to do this, or forgot to do that, or somebody just completely messed up on what they're saying. So it's really, really fun to watch the live stream because of all the antics, right? It's like the Marx Brothers sometimes. It's just it's just insane, right? And then they have a after show that they call um, um, After Dark, and this is just them shooting the breeze. If they have a guest, they'll oftentimes talk to the guest even more, right? And guests actually usually say a lot more at that time than actually during sort of the formal show. So yeah, it's great fun, and definitely check them out. So Todderbert is in the chat. Hey there again, Todderbert. Nice to see you. Uncle Bill, of course. Yeah. All right. Well, cool. So
Cosmic, about that other Soyuz launch, that was about 5 days ago, I think on the 25th. Everything went well as far as I could tell. It was a Russian military communications satellite, so there weren't a lot of details about anything, about the mission, except that the launch went up and they deployed it.
oh, cool. So I mean, it sounds like everything worked as planned. So good, excellent. That, yeah. I mean, I think I forget who it was. Was talking about, quality control and all that with Russia might be going down a little bit, and yeah, that might be so. I don't know. It'll be interesting, to hear or see the official report, because yeah, I mean, if it was like negligence or or worse, and it's like, that's pretty bad, right? But can mistakes be made? Yeah, absolutely. But I think, in most systems there's a lot of redundancy. So if sort of the primary thing fails, or the secondaries can sort of take over. I don't know if that is sort of the case in terms of Soyuz or rockets in general, but yeah, I think probably lots and lots of things have to fail to have that kind of an event. So yeah, more Russian satellites. Oh yeah. It's called the space race, right? Yeah.
Now,
Well, wait.
I did tell you while I was on the Discord earlier, looking at the Soyuz malfunction check. I did tell you about the crew return vehicles, or CRVs, and what could be their plan Bs.
Yeah. What? Why don't you expand on that a little bit, Bobby?
Yes. So, according to Wikipedia about the crew return vehicles, it never caught along. So, what they did, they had like 3 ways. There used to be 3, now there's 2, for when it comes to CRB style kind of things. You can the one they use to have is a space shuttle. But then there's the Apollo module and the Soyuz module. What I really do think is, because there was a failure in October, why won't the Russians just launch 2 rockets? One for the man crew and one for like a robotically driven vehicle. So the next time, if the man crew has another ding it moment, and your robotically driven vehicle module is still peachy, at least the crew will still have a vehicle to lean on just in case there's an emergency. Because I don't know right now if they really do have an emergency module.
I think, I mean, what I've observed, at least, is that if there's any kind of emergency or anything, the Soyuz is going to step up, right, and get those guys out of there. You know, you'll lose the hardware, but you know, at least you probably won't lose the people. So yeah, I think that worked amazingly well, and I think that's awesome. So, you know, I think the plan B should be proceed, right? Just, you know, make sure, right? Make sure that everything's screwed down, and make sure, you know, that things that have to be looped are looped, and you know, all of that, and just proceed, because I mean, it sounds like it sounds like they are going to do a crewed launch on the 3rd of December, right? So that's just like a month away or so. The ISS has a reentry vehicle in a sense that it always has, I think, one extra Soyuz that's attached. So I don't know if they have any kind of escape modules per se, but I know that they always have, and I think this is right, that they always have like one Soyuz up there that I think is part of the rotation. Is that right? But yeah, I think they always have an extra one too. So you know, I think you'll always see at least 2 Soyuz up there. Is that right?
Yeah,
Tom?
yeah. They always have what they call a lifeboat, which is for emergencies. If someone on the space station gets sick or, you know, has a medical problem and they need to get them back to Earth for you know, medical reasons. And I think right now there's at least 2 that are still attached. I think the one issue is that those craft are certified for a certain number of days after they attach them to the space station.
Yeah.
And so I think the one that's there, the lifeboat, I think its certification would run out sometime in January. I don't remember the exact date. So then they, you know, have to figure out what to do if there's still crew on board. But for right now, they've got what they need in case of any emergency. Yeah,
and I think, I mean, it sort of looks like, right? I mean, full speed ahead in terms of crewed launches. So, you know, only lost a month, so not bad, month and a half, whatever it is. Yeah, it sort of seems as though there really isn't. Well, it doesn't sound like, you know, there's going to be like any effect on sort of the schedule of the station.
The bill has 2 messages. That re-entry vehicle is peroxide powered, and its fuel expires in December. The worry is leaving the ISS unmanned and unmaintained for any length of time.
Yeah. I've heard that the crew has to spend like 2 hours a day just in maintenance. So, you know, I mean, if you sort of multiply that, you know, I mean, if there's no crew, you know, you multiply that by, you know, X number of days, right? I think, yeah, you know, I mean, it's not as if, you know, the space station's going to, like, you know, disintegrate or fall apart or anything, but it seems as though, you know, they have to be pretty active in terms of maintenance. So, you know, that tells me, right, that they're just like, you know, on this really, really thin wire, and, you know, they're trying to maintain that, and that takes, yeah, I mean, if it takes 2 hours a day, you know, just to maintain things and make sure things aren't falling apart, then yeah, if you don't have a crew up there, things are going to get pretty bad pretty fast. So yeah, that's amazing. And
Yeah, and Uncle Bill Duran also NASA doesn't want our new commercial crew vehicles stuck in an unmanned ISS, so you have no choice.
yeah, absolutely, yeah. I think
Let's just hope and pray we don't have an abandoned ship.
yeah, and it doesn't sound like it. I mean, if I guess I would say, and maybe I'm completely wrong here, but I would say that if there's another mishap, right? I mean, really, if anything goes wrong at all on this coming launch, then NASA, at least, is not going to send anybody else up there. Away, right? Maybe I'm completely wrong about that, but
I mean, if there's going to be another failure, that's really going to make NASA matter.
Well, I think so, and rightly so, right? But yeah,
that's when I think you will have to abandon ship. Is that correct?
well, I don't know. I mean, the crew that's up there now can certainly survive quite a while, and we do have ways of sending them supplies, right? So I mean, they're not going to run out of food and air and water and all that kind of stuff. They just either won't be able to come back, or if they do, yeah, they'll have to abandon ship. But yeah, I would think that if there's another mishap on this coming launch, then Soyuz is probably going to be grounded for, I don't know, maybe indefinitely, right? Don't know. I would have thought that maybe they would have spent a little bit more time on this current mishap. But if they think that they have an understanding of what went wrong, and it was just sort of like, we messed up on this, and it's extremely obvious, then it's like, okay, all right, try again. I mean, if everybody's on board, right? I mean, if the people who are going are saying, sure, I'll go, then it's like, well, I mean, those are really the people who count, right? Those ones sort of have the say, to a certain extent. And so if those folks are confident that this December 3rd launch is a go, then who's anybody else to say no? So yeah. So yeah, it's exciting times, and I mean, we definitely need.
Should another thing it has to happen, what is the possibility that the crew have no choice but to abandon ship?
Well, like I said, they can probably be up there for quite a while, right? Because we do have means of resupplying them. So, but how long do you want to keep some people up there, right? I mean, it's a pretty nasty environment. So there's
a possibility if the Soyuz cannot be trusted, NASA will have to find some ways how to save the ISS and stuff, right?
Yeah, I mean, those folks will eventually have to come down, which they'll be able to do, right? There's, like we were just saying, I think there's at least one, if not two, lifeboats up there right now. So, they can get down, no problem at all. but yeah, if that means leaving the station crewless, then not clueless, crewless. Yeah, that's probably not a good idea. And I'm not sure with the crewed. Well, Soyuz docks by themselves, right? I mean, they come up to it and actually physically dock. The is that right?
Soyuz has automatic docking. Yeah.
Yeah. But I think with the resupply missions, the uncrewed stuff, they usually fly the thing up close, and then they use one of the station arms to grab it and dock it. Are they? What are they going to be doing with the crewed U.S. stuff? Is that going to be an arm grab thing?
I hadn't heard if they're going to do that or use the automated stuff too.
Yeah.
I don't know.
Okay. Because I mean,
that'd be
if
great if they use the automatics, and also Uncle Bill has said, worst case scenario, he has no doubt another Soyuz vehicle can be sent unmanned to replace the lifeboat that will aspire.
yeah, yep, totally. As long as Soyuz can fly, right? I mean, if they all of a sudden have sort of this series of failures, then but that's probably a stretch. I mean, one failure is very unlikely. 2 in a row is like almost impossible. 3 in a row is I mean I can't even imagine that. So yeah. So
what do you expect? The 2 in a row failures or 3 in a row failures?
well, I don't want to expect any failure whatsoever. One is bad enough. So 2 is unlikely.
Soyuz has a great history too. I mean, they really haven't had very many failures at all.
Yeah, Soyuz, well, that name at least goes back to the 60s, right? So the rockets have changed over the years, but that name and sort of the basic, sort of the bones are the same. So yeah, I mean, extremely reliable, and that's why I say, even having one failure is like really, really unlikely. To have 2 of them, ooh, that's almost impossible. Okay, so
the commercial cargo is berthed,
right,
not docked. The SpaceX Crew Dragon is supposed to have a new docking port, but it's not been real well tested.
Okay, so I guess what Uncle Bill is saying there is that the crewed Dragon is going to dock itself. It's not going to be grabbed and then docked. So because I mean, if we don't have anybody on the station, right? If the crewed Dragon, say, needs to be grabbed and actually brought in, well, there's nobody to do that. So they might be able to do that actually from the ground. So maybe that isn't impossible. Maybe it's a little bit easier there because you sort of have a live feedback, right? There isn't any kind of delay or anything. I think communication with the ground, my guess is that there's a little bit of a delay, probably not much, but yeah, cool. So yeah, so Soyuz is look like it's going to be going, and we got word today, I guess, that the Kepler spacecraft has finally run out of fuel, and it's this fuel that allows it to move, and I don't think that they necessarily use that fuel to to track or anything like that. They probably have reaction wheels and gyros and all that kind of stuff. but you know, sort of to move around big motions. They are out of fuel to do that. So Kepler has officially been put to rest. So Kepler is no more. It is now space junk out there. Well, where is Kepler? Is Kepler at L2?
Don't know. Let's take a look.
I don't remember either. I don't think it's in Earth orbit, but maybe I'm wrong about that.
It's assigned to be capable, but NASA's already stated that it will not allow any commercial crew to dock at unmanned station, if he understood Ben Credible correctly.
Okay. Yeah, yeah, I don't think that Kepler's at L2. I think it's in orbit. I think it's a big orbit though, right? Like 1,000 kilometers or something. I mean, it's a big orbit. It's not GEO, but it's one of those big orbits. I don't think it's at L2. But yeah, Kepler is no more. No more fuel. No more way to move around. No more. Yeah, I mean, it's just going to drift, right? I think. So yeah, I mean, if it drifts, there is no way to collect any kind of relevant data, I don't think. Yeah, it's.
And the Hubble's back to square one, right?
I think Hubble is back operational as of now. Yeah, I think so. I saw a little bit of news about that. So that's extremely cool, and like I was saying, to all the technology nerds out there, right? How many times has like this big problem of yours been solved, right? By turning it off and turning it back on, right? I mean, it's incredible how much that fixes things. And in terms of Hubble, that's what they did. The gyro that was giving some bad data, they cycled power on it, and apparently it's working just fine.
Kepler is an Earth trailing solar orbit, but not ESL4 apparently.
Okay.
Or Earth trailing.
Yeah, I gotcha. Yeah, so maybe around L4. L4. Wait a minute. L4 is the leading one. So I think L5 is Earth trailing. Is that right? Find anything else out about that, Tom?
The only thing I've seen so far is what Uncle Bill said. It's an Earth trailing orbit. I did see that they said it's a little slower and a little bit bigger than Earth. So it's about 371 days as it goes around the sun.
Oh, yeah. Well, Kepler is no more, and what there's still a couple of things that I have to investigate and understand about Kepler, especially the detections. Right? I want to know.
Okay, Uncle Bill gets L4 and L5 confused.
Yeah, it's sort of like left right, But yeah, I still have to research the methodology of actually detecting these transits, because yeah, I just have to understand that a little bit more. And the one thing that I've yet to find, but I think I might have actually just found it tonight. Kepler takes images, right? I mean, actual pictures, and then makes photometric measurements of these stars using those pictures. And now I haven't tried really hard But once in a while, I've tried to actually locate these pictures because that, you know, those to me are as valuable, if not more, than the actual light curves. Which, you know, the light curves you can find; they're just there, right? But the images, I've always had trouble finding those. But I think I actually found them over on MAST, over on the what does MAST stand for? I'm gonna go over there and look because I was just over there moments ago. The Mikulski Archive for Space Telescopes. So this is just all, well, sort of the hub for space telescope data of all sorts. And of course, Kepler is a space-based telescope. So all of its data is there, even apparently, even the pictures, which like I said, I have never been able to actually find, but because of the occasion, I well, I'm going to try to look again and see if I can find anything. And here, I'll share my screen here. I'll show you what I found. Let's see, share desk screen, like that. Go to infinity, and we'll go over here. So this is, I think this, I'm not exactly sure what this is from. Here, let's try to find out. Oh, I grabbed this document, which is, you know, sort of the document that is going to describe the data, how it was acquired, how, you know, all of that, right? It's only 392 pages long. So I'm going to have to, you know, dive into this a little bit because they, here's the contents, right? It's just,
Horizon Sci on Twitch is one of the scientists that researched the techniques of Kepler's directions.
Cool, nice. No, I've actually got all the papers that were written about how detections are done, but they're like just absolutely huge, long, detailed, involved things, and you know, I have to find a nice block of time, you know, to go through all of that. But anyway, so, you know,
and Horizon Sci has worked about 70 papers about it.
Wow, cool. Okay. I will have to check that out a little bit. Yeah, cool. Interesting. All right. Yeah, I will have to check him out a little bit more. And he's actually one of the scientists that worked on all the techniques. Very cool. Very, very cool. All right. Well, he would definitely know. So yeah, I will check him out for sure. Anyway, so yeah, you know, this is just long and involved and all that, but it looks like, in fact, I guess what I'm going to do here, let me grab this really quick and save it so I don't have to reload it. But how was I getting there? K2 data products. Is that it? No, that's not what I was doing. I was going to K2 on MAST. Download it here. Well, I guess that is it. Okay, yeah. Anyway, I'm going to have to look through this a little bit more because actually this is not where I originally went to, but it looks like it's got full frame images. That's what we're looking for. So cool. All right. How to download. Okay. Yeah. I'll have to poke around with this a little bit more. But anyway, I was able to find stuff like this, right? Light curves over periods of time, and then appear these things called target pixel files. So don't know what those are yet. They are FITS files, extended FITS files that have binary tables in them. So yeah, that's going to take a little bit of time and effort to extract. So I'm not quite sure if these are the images or not yet. Not quite sure. Maybe what we're finding here, or what I'm seeing here, full frame image. Oh, here we go. Okay. So I'm going to have to dive into this a little bit because...
and they're all in FITS.
Yeah, they're all having FITS, and they're big. 389 megabytes each. So, yeah, these are big.
How do you open FITS files?
You know, I did a live stream about that a few months ago. Could probably talk about FITS files again at some point. One of the ways, at least, is there's a Windows program called what's that called? FITS. Oh, I forget what it's even called. Let's see if we can find out. FITS helper. FITS liberator. FITS liberator. Liberator.
Looks like it's also for the Mac as well.
Yeah, I sort of noticed a maybe a Linux thing now too. I'm going to have to look and see. Anyway, FITS liberator. Yeah, here for so Mac OS 10.11. But not 10.12 apparently. Anyway, so yeah, FITS Liberator is one way to sort of view FITS files under, I guess, Windows and Mac. So definitely check that out. There are other ways to look at FITS files, but actually FITS Liberator is a pretty nice tool. You know, you can look at the header, all the metadata. Yeah, it's pretty nice. Let's see if there's I don't really see any. Here's just a screenshot, which probably doesn't do it too much justice, but you can sort of see here a little bit. It's you know, gives you all the metadata, gives you the image. Here's a histogram of probably the brightnesses, right? So that's pretty cool. And then I think you can save these, you know, these images as JPEGs or PNGs or whatever. So yeah, I don't know if you can like edit the headers or anything like that. Not quite sure.
Now, can you actually colorize FITS images or no?
Well, data itself has no color, right? It's just brightness. So it's a grayscale thing. In order to get color, we humans have to assign colors, which, you know, are, you know, I mean, you can choose what colors to actually use, right? But I mean, usually these astronomical images are, you know, that data is collected using different filters, right? So you might use a red filter and a green filter and a blue filter. And what you would do then is take those three images and say that one's red, that one's green, and that one's blue, and then combine them. And that actually makes a color image. So yeah, there really isn't any color per se in this data. It's just, I mean, we sort of assign things colors. And we've all agreed, you know, that red is red and green is green and blue is blue, right? But yeah, that's sort of an arbitrary decision, right? So really, you know, surprise, but you know, color doesn't really exist except in our own heads. It's just different frequencies of light. That's all it is.
Mm-hmm.
And there's a frequency, and there's an amplitude. So we have a brightness, and we have a frequency, and that's it. And so that's why all of this data you'll ever see, actual science data, is grayscale, because that's actually what it is. We assign all those colors all by ourselves. Anyway, so yeah, Fitz Liberator, great package. I'm not quite, you know, I'm not quite sure how to interpret this. If it, have they put all the data into like one Fitz file? Is that all? This release of K2 data, is it all there? I don't know. Not quite sure. Here's a README file. What's the README file say? The FFIs contain values for every pixel in each of the operational output channels. Yeah. Yeah, that doesn't really say much there about that. But anyway, Kepler obviously has done some incredible work, and you know, even having sort of a hardware problem, they were able to overcome that, and you know, that's good engineering, right? Well, and when I say engineering, I mean, you know, not only the mechanical part of it, but also the software, right? I mean, but obviously, there are some absolutely brilliant minds that, when confronted with that kind of a problem, have a spacecraft, right, that is designed well enough to be pretty flexible, both with the hardware and the software. And because of that, you know, they can take a disaster and actually turn it into something that's absolutely incredible. I think, and correct me if I'm wrong, but I think they've discovered more exoplanets on the K2 mission than they did with the first mission. Is that right? Or was it about the same? I don't remember.
I don't remember either.
I think it's my guess is mainly because of time, right? I think the original mission up to the failure, I think that lasted just a couple of years. But they've been running K2 for, wow, I don't know how long. 4, 5, 6 years. I'm not exactly sure. So yeah, I think you know, maybe just a matter of time. They've, you know, because they've had more time, they've just had more opportunities to discover these guys. But what are we up to now? Something like 3,500 confirmed? Is that right? So yeah, that's pretty amazing. Pretty amazing. So cheers to exoplanet.
Yeah.
I'm this is one of my gripes though, that a lot of astronomers and a lot of people who are interested in astronomy seem to me, I don't know, to be a little overexcited about extrasolar planets and finding life signs and life and all of that. You know, the study of life is not a topic of astronomy, right? It's a topic of biology. And there are at this moment people who call themselves astrobiologists. I'm not quite sure what they're doing because they have no data to work with. So I think they're modeling and theorizing a lot, but so far the astrobiologists don't have anything to do in terms of actual data. So I think I think astronomy, you sort of move away from astronomy, I think, once exoplanets are discovered and maybe analyzed, right? Because you need, at least at the moment, you sort of need the tools of astronomy in order to get the photometry, in order to get the spectra, and all of that. But I mean, once that's done, the astronomers, need to step aside and hand this data off to, the astrobiologists and the biologists and the chemists, right? Those are the people who should be really, really excited about these kinds of things. Being an astronomer, and like I've said, I mean, my reaction to exoplanets and possible life elsewhere and all that is, one, I'm not surprised at all, and two, I think there's going to be more. I think it's everywhere.
Now, can you convert them into 3 JPEG images to colorize them?
Yeah, and in fact, Bobby, that's exactly what I do on this live stream. When we go over to the HST site, I just grab those first images that we see. Those are JPEGs. It isn't the raw data. It's, I mean, JPEGs are, compressed things. The data, those data values really aren't scientifically valid, right? But what we're doing there, right, is just sort of combining pictures. So for these kinds of purposes, the live stream, that is adequate. That is adequate. But if you want to do actual science, right, you have to grab that FITS data, because those are the actual numbers, right? I mean, CCD cameras, right, are basically just, huge arrays of photometers, right? And so, when you look at an image, you can look at the pixel values, and those values, those numbers, are directly related to, the brightness and the spectral response and everything else that goes with that object. So you got to have.
But every once in a while, we can look at the Kepler data.
Yeah. Like I said, I think once I sort of find that source, then I definitely do, because I mean, just for my own research, right? I mean, I I I don't know how much data there is, but I think that there's got to be tons and tons, like terabytes, right? Um, and yeah, I just have to find it. And I think going through MAST, the archive, I think that is definitely the way to go. But yeah, I've sort of yet to find the actual pictures, right? And maybe the site that we just looked at now, maybe that's it. I'm not sure. So, but yeah, I mean, I would actually really, really like to have that kind of data, because I think there's a lot that can actually be done. I actually posted a link to a paper that was submitted um, or placed onto the archive yesterday, and let me see if I can find it here, because it was kind of interesting what they said. And I'm going to hide that, and I'm going to go over here, papers. So this is a catalog of 29 clusters and associations that were observed by Kepler and K2. It's a very short paper. This is a list. That's all it is. It's just a list of the clusters that have been observed by Kepler over the years. And there are quite a few, but I like what they say here. This is sort of a call to action, right? So while the science return thus far from the clusters of Kepler and K2 has been excellent, only a fraction of its potential has been mined. So only a third of the observed clusters have been studied. So they're providing this entire list saying, look, folks, go into the Kepler archive and look at this data, right? Because it's all there for all of these objects. And I gotta say, I mean, I can be, I'm pretty confident in saying that there's probably some interesting stuff there that that we have absolutely no idea what we're going to find. So that is definitely a call to action. To see what else can be done. And
so NASA's giving you some homework.
And anybody else too, right? This data is freely available. I guess you just have to find it. And I always hope, and I've looked at a number of these kinds of papers, right? And I always hope that they say, here's a link to the data. And this one again doesn't have any link, no reference at all, right? Just references to pixel files, right? Which is what these things are, right? So that's why I think these are the images. They're just in sort of a not so easy to access format.
It's a gzip fits file that you need like an archive manager that can do gzip to extract the fits.
Yeah, but then the fits file itself is formatted in kind of a strange way, so it's not straightforward at all. So yeah, that's gonna.
Yeah, it's probably a bit messed up. They didn't find out where you find this data unless you do your research.
Yeah, I think it's just a matter of figuring all that out. this might be it.
I believe if you can grab some of that information from those spit spouts, I think you're in the right track.
Yeah, I think so too. All right, well, hey, I think that I am going to get out of here for now. It's about that time, and I'm going to go crash and burn here pretty quick. So let me check
did you say that tomorrow through the 5th UTC time, you're actually going to be at that conference?
Yeah, I was just going to mention that I'm not going to be doing a live stream for the next 4 or 5 days or so. Let me see. I'm looking at the calendar. I think the next time that I will have an actual live stream will be 2 hours UTC on the 6th of November. So I'm going to be out the 1st, the 2nd, the 3rd, the 4th, and the 5th. And I'll be back. I think that's right. Yeah, I'll be back on the 6th.
And that means ADL will start 8 o'clock local here, Central.
Correct. Yeah. Now, yeah, and I think there's a time change this weekend too for most of you. So yeah, you have to take that into account as well. I mean, I have to think of that too, although I don't actually shift times. But I do have to be aware, that the rest of you do. So, okay. All right, well, cool. So, yeah, this will be the end of the live streams until next month. So, hope everybody does well. Yeah, I'll be traveling tomorrow. And then, yeah, I'm sort of attending this kind of, well, and I'm not really an attendee. I'm part of the entertainment. So, but they've allowed us to sit in on the talks and go to the dinners and all that kind of stuff. But we're going to be playing twice. We're going to be playing Thursday night and Saturday, or Thursday night and Friday night, or Friday night and Saturday night. I forget. Going to be playing a couple of times, probably in total maybe 2 or 3 hours or so of nice, of really nice Native American flute music, and my musical partner is really good. Makes my job on this keyboard here really easy. This keyboard will be going with me, along with the stand and the backpack, and I've got an amp here. So yeah, all the stuff we got to lug up there. So, all right. Well, with that, I will wish you all goodbye for now, and yeah, I will see you in several spins of this planet. So definitely don't get too dizzy. It's it's pretty spinny, but hold on to your hats, and all will be well. So yeah, I will see you again on the 6th of November at 2 hours UTC, same time, same place, all of that. So I think until then, friends, peace, cheers, and all that. And I will see you later. Bye.
Have a good conference.
Later.